Hello everyone and good evening. Welcome to today's tutorial. This is week 2 tutorial of for the course Biostatistics and Experimental Design. I hope you're all on the same page. I think week 3 assignment is due this week, right? If I am not mistaken. And yes, someone's raising a hand. I'll just Archana. Yes. Oops, I was muted.
Your audio.
Okay. Yes, sorry.
Yeah, yeah.
Hello, good evening, everyone, and welcome to the second tutorial for the course Biostatistics and Experimental Design. Um, so, I'm assuming all of you are doing your week 3 assignment, if I'm not mistaken, and that's due in some time, few more days, I guess, or maybe tomorrow, I don't know. So far, so before we start off, just some ground rules. If you wish to speak, you can just unmute yourself and start speaking, and I can come back to you. And also, if you're not speaking, please be muted. And one thing is, when I actually share my screen, I cannot see raised hands or prompts to admit people. So if you could just alert me then that if there is someone that wishes to just trying to join and they're not able to, please let me know. I'll admit them because I can't see the notifications. I'm just working with one screen. Okay. So that's just to have some ground rules established. And now moving on to the main tutorial itself. Anyone having doubts so far as to the regarding the content covered? Yeah. Anyone? Over the past few weeks, you can just speak up if you have any issue regarding the content covered, any clarifications you need, any conceptual clarifications, things like that. And before you speak, you can just like tell us your background, where you're from, and then it's better to know each other via this class as well. So I don't hear anyone saying anything regarding the previous content. So I'm assuming everyone is okay and they've understood whatever has been covered. Okay, so let's move on now. And what we will do this in this tutorial is solve an assignment that was from the previous year, and it is actually very similar to the assignment you have. Only I think the values are different. But we'll go over that, and while we are doing that, you can ask me questions if you have. Let me arise, okay? And you can please feel free to stop me whenever you have any burning question, and I'll try and answer those. Okay. Okay. So the week 3 mainly dealt with, again, it's all parametric tests. You did a t test, you learned about t test, f test, and ANOVA. Okay. A quick question here. What are the conditions for a t test? Well, like when can you do a t test? Anyone? Can you speak? If anyone can answer this question, when can you use a t test? Yeah?
T-test is done to uh, check mean against with the population.
Sorry, come again. I couldn't hear you properly. Pardon?
T-test is done
Yes.
against sample mean and the population.
To compare means of the population. Yes, yes. Of two different populations, right?
Yeah, so if it is student T-test, it is done within 30 sample size. Then you have one tail T-test and two tail T-test. You also have three T-test. Sorry. So three T-test is done between the
Ma'am, your mic is slightly problematic. We can't hear much about what is. But I get a brief just of what you're trying to say, that you do a student's t-test to compare means of two populations, and you can do a one tail t-test, two tail t-test. Is that what you want to say? Okay, maybe the connection is, yeah. Okay,
Connection issue. Because I'm driving.
okay, no problem, no problem. You can maybe type, yeah. If you're driving, then please drive. Yeah. Okay. So yeah, t-test is done to compare means of two populations. Some conditions need to stand when you want to do a t-test. One is your data points should be normally distributed. Okay, and your variances should be very similar. It should be both the variance of both the population should be very similar. Similar. They cannot be very different. Okay, these are the two most important criteria for doing a t-test. ANOVA is just an extension of a t-test where you can compare more than two groups. Like in a t-test, you can just compare two groups. In ANOVA, you can compare more than two groups and in different ways. There are random factors, fixed factors, and things like that. We won't get into those now. Okay. But yeah, so you just started doing what F tests were, what ANOVA was, and I think in the next week you will do a little more of ANOVA, where you get into all these fixed factor, random factor, things like that. But for now, I think if you know t-test, you'll be able to get this assignment. So let's go on with the questions. Actually, uh, okay. So the first question is there are two drugs, okay, and these two drugs are designed to reduce the glucose level in the monkeys in their blood, I guess. Yeah. Now, when you actually
Sir,
test how sugar levels drop when you administer one drug versus when you administer the second drug, the difference in sugar levels is given by the following values: -4, -3, 5, 6, 5, and -4. Okay. This is the output of an experiment you have done. You have administered both these doses at different time points on say each same animal. On one animal you administer the same drug, okay, and each time you administer one type of drug, you calculate
Can
some.
sir.
you please share your screen?
Oh, sorry.
Yes, sir. Your screen is
Okay,
not shared.
yeah. Sorry, I will do that. Uh, I'm just very new to this. Okay. So there are two drugs, and so for which are designed to reduce the glucose level of monkeys. And what maybe how the experiment was done was you have the drug A you administer, you record the glucose level. Maybe after a few days, when the glucose levels go back to their whatever normal steady state is, you again administer a drug that is drug B, and you measure the glucose level. So you, for each animal, you administer this drug, each of these drug A and drug B, you record values and you record the difference between these values. And these were the values that were obtained: -5, -3, 5, 6, 5, -4. Now, given this data set, you need to say whether one drug is better than the other at reducing glucose levels. Yeah. And that alpha, that is at the significance value of 95%, that is 0.05. So what kind of test can you use here? Anyone? Yeah.
It is t-test.
Yes,
Simple
t-test.
t-test.
Okay, and what will be your null hypothesis here? What will be your null hypothesis and what will be your alternate hypothesis?
The difference between
T-test,
drugs is
both drugs are equal.
Yeah, so tell me in mathematical terms, what, if they're equal, what should the difference be?
There is no difference between the two drugs.
Yes. So formally
Two drugs are
stating,
equal, we can say.
yeah. So formally stating, the null hypothesis will be both are equal, which should mean that the mean difference should be zero, right? So this is important. Mean difference should be zero. Okay. What is the mean of the, so this is your null hypothesis. Alternate hypothesis is both are unequal. One could be greater, one could be lesser. So this will not be zero. This could be +1, -1, +0.5, -0. Anything but zero. That's the alternate hypothesis. Now, when I calculate the mean of all those values that were given, it was 0.833. Okay, and the standard deviation of that was 4.95. Number of samples was 6. Okay, I use these three values and I try to and I find the t value, which is nothing but mu minus 0. This 0 is important here because that's your null hypothesis. Okay, this is your null mean. Null mean should be 0. The observed mean is zero point 0.8. So mu minus 0 divided by standard deviation by square root of n. N is your sample size. It's just you just have to substitute values in this formula. And when you do this, you get a t value of 0.411. Okay. Now you need to compare this value against the value at which alpha for alpha 0.05 the result would be significant. So you need to find the t value for that. How can you do that? You can look up a t table. Okay. You can do this on Excel, but I'll show you a t table. I'll show you it on Excel also. Yeah, Byju's is giving us a detailed, but yeah, it's very standard, so it should be correct, I'm assuming. So we are doing a two-tailed test here. See, you should always be conservative beforehand. Always do a two-tailed t-test to see whether things are unequal. If they are unequal, go ahead and do a one-tailed t-test. Okay, and actually there's no difference. The test is the same. Only the values of t will differ. For example, for one tail at zero point 0.5 at for degrees of freedom thing will be this, and for two tail for this significance it will be this. That's it. Okay, only the t values will differ. Until then you don't have to actually change the way you calculate your t value. What you compare it against will change. Now for a two tail t test at 0.05, for how many degrees of freedom do we have here? Yeah, so we have 1 2 3 4 5 6. Okay, 6 values. So what are the degrees of freedom that we have here? Can
Is
someone
n
tell me what
minus 1 to 5.
n minus 1? Can someone tell me what degrees of freedom is? Don't tell me the formula, tell me what you mean by it. Tell me what you understand by degrees of freedom. So what I understand degrees of freedom is the minimum number of samples you need to specify so that you get the entire set of values of a set of any given set. For example, in this set, if I specify if I give you first 6 numbers, I give you all these 6 numbers, okay? Suppose I gave you all these 6 numbers, and now I start calling out each of these. So I call it -4, -3, 5, 6, 5. If I've called out 5, I know for certain which number is left with you. Okay, and that is has to be -4. Okay, so in that way, I need to call out the 5 numbers because once I know all the 5, I know the 6th number as well. So the minimum number of numbers, samples I need to know to define the entire set is degrees of freedom. So here it's n minus 1, which is 6 minus 1, that is 5. So if I call out 5 numbers, I know which one I've left out. Okay. Did you get the logic here? What degrees of freedom mean, at least in statistics, not in physics? Yeah. Did everyone get what I said? This is a simple thumb rule that you can keep in mind.
Yeah, minimum number required to understand the other remaining number
Yes, yes, yes,
value.
yes. Maybe I'll just admit people.
Excuse me. Can you? Hello.
Yes,
Can you hear me?
yes, I
Can you? Would you
can.
mind repeating it?
Okay, yes, I will do that. Are there? Yeah, I'll just admit people. People still joining in. Okay, yeah. So what degrees of freedom is that given a set of numbers or samples, okay? For we can take the example from the question itself. Suppose I gave you all these 5 numbers and I asked you to keep it with them in a bag. Okay. And now I start calling out numbers. For example, you start giving me numbers. So you give me the first number, it could be -4. Then you give me the second number, -3. Then you give me the third number, -5, 6 and 5. So on, okay. When you're given me 5 numbers, I know for sure what the sixth number will be. It will be -4. Yeah. So these are the minimum number of samples that you need to specify so that someone else can tell you the entire data set from where you have sampled. Okay. Given he has prior knowledge of that sample. Okay. Did you get that?
Yes, I got it.
Yes.
Thank you.
Yeah. So here you need to specify at least any five of these number. You specify any five, I can tell you the sixth number. Okay. So that's n minus 1 here. So you have how many? 5 degrees of freedom. Now why is 5 degrees of freedom important? When you look up the t table, for 0.05 two-tailed significance, what is the value for 5 degrees of freedom? 2.571. So this tells me for a t value of 2.5 or greater that whatever test you do is significant. Okay. What is the value that we obtained here? 0.88. Sorry, 0.411. That is much lesser than 2.57. Okay. So you reject the alternate hypothesis and you don't reject the null hypothesis. What was the null hypothesis? Both are equal. So you fail to reject the null hypothesis. Correct statistical statement would be failed to reject that both are equal. So this is the conclusion you would draw from the statistical test you did. Okay. I'll show in Excel how to get this t value if you don't want to look up tables. So this is just a thing you just have to type t dot inverse dot 2t for a significance level and you need to define the degrees of freedom. Okay. That's what the table also needs. It just needs two values for you. It needs the significance for one tail or two tail. For two tail it was 0.05 and how many degrees of freedom. Given these two, I can tell you what the t value is. Same thing here. Okay. So that was 2.57 and what we got was much lesser than that. Okay. Which is why you fail to reject the null hypothesis. Okay. Next question is, in a clinical trial, okay, this is a verbal thing and someone should tell me both the answer and the logic behind this. In a clinical drug trial, a drug X was tested with a placebo and it was found to be better than the placebo with a p less than 0.05. Okay. Then in another clinical trial, a drug Y was tested with placebo and it was found to be better than placebo with a p less than 0.01. Okay, pick the right answers. So these are your options. I hope you can read them. Drug Y is better than X, drug X fails in the treatment 5% of the time, drug X is effective. Let's tell me, let's take them one by one. But is drug Y better than drug X? Can you tell this to me just by reading this?
Here, p-value is not provided actual. Here, actually, in both the cases provided less than. So we cannot directly interpret the direct correlation A equal to B. This is my opinion.
Yes. Okay.
I
And
want to know.
also, p value does not tell whether one drug is better than the other. Okay.
Yeah, I want to know.
Yeah.
One p value is less than 5 degrees, 0.05. Another one is 0.01. Can we compare when there are 2 degrees of this thing? There are two p values. It is not the same p values to compare, Alva.
Yeah. Yeah.
Both of them should be either 1% or 5%.
Yes. Yes. So yes. So how you would actually compare this is you would actually take values for drug X and drug Y and do a t-test between those. Okay. At some significance level. Only then you can tell whether one is better than the other. Okay. But why do we use p values? What kind of error do we try and minimize with p? We did this in last class. When we reduce your p, like the criteria for p less than say 0.01 or 0.0, what are we trying to do when we reduce? What kind of error do we try and reduce?
We try to reduce type 1 error.
No, yes, type 1 error, false positive. We try and reduce the false positive error. So we can say using this that drug X, because it is tested with a higher thing, it has a higher chance of giving me a false positive than drug Y. Okay, it does not mean that drug Y is better. It's just that the false positive is, it could be less effective than drug X. Okay, but with a higher confidence, I can say that drug Y works than drug X. Okay, it just does its job that it was designed to do. So the answer to this is we can say with more confidence that drug Y is better than the placebo. Okay, you can't compare X and Y, you can just compare it with the placebo, and you can say I have more confidence because your type 2 error is type 1 error is lesser in case of Y because P less than 0.01. So using that criteria, the false positive rate is lesser. That's why my Y is better than the placebo with a higher confidence. Okay, did everyone get this? Yeah, and I would like to draw your attention to these two. They are very similar. P less than 0.05 does not mean that drug X fails 5% of the rate. It's not like if I administer a drug for 100 people, it will work 95% of the time. No. Okay, that is not the meaning of P less than 0.05. It tells you with what confidence this drug will work. Okay, it's different, and please don't confuse one with the other. Okay. P value tells us given your data, it will tell you whether your drug works and with some confidence that the drug will work. It will not tell you like, okay, out of 100 people, 95 people it will work and things like that. Okay. It's a very data dependent statistic, this P. You can't generalize in a manner that I said earlier. Okay, is everyone clear with this thing? It's very important actually. I think it's the most important question in this assignment. Yeah?
Sir, I have one doubt.
Yeah?
Sir, when we reject the null hypothesis,
Yeah?
how can we decide that the drug A is better than drug B or drug A is worse than drug B?
So you can do a one-tail test. Okay?
Yes.
When you do a one-tail test, you will know whether one is better than the other. How do you know? If it's positive, if say mu A minus mu B, the value that you get is positive, and in one tail it's under whatever significance, it comes out to be significant, that test. Then you know A is better than B because your difference of means is positive. If the difference of means is negative, then you know it's less. B is better than A. Okay?
Okay, sir.
But you need to do a one-tail t-test. For greater than, lesser than, for all these inequalities, do a one-tail test.
Can you please repeat the words for the better understanding of all the members?
Yeah, yeah. So the question was, how do you determine one is better than the other, drug A or drug B? So you will have to do a one-tail t-test. So the formula is the same, but when you look up the t-table, the values that you will have to look up will be slightly different. For example, for one tail, you see that it's when alpha is 0.1 here, for two tail it's 0.2. Okay, so you need to look up appropriately. So for one tail t-test at 0.05, you have to look up this thing. Okay, and if your t value is greater than, for any given degrees of freedom, it's greater than whatever you obtain here. For example, for degrees of freedom 6, the t value is 1.94, you get a t value of say 2, then you accept the alternate hypothesis, you reject the null hypothesis. Okay, and how do you determine one is greater than the other or lesser? You compare the means. If mean of A is greater than mean of B, you know that A is better than B, and if mean of B is greater than mean of A, you know B is better. Okay, I'm assuming. So did everyone get that? Did everyone get that?
Uh,
Okay,
Final line. So,
final line
so
is, yeah.
A in mean in that particular case, what I understand that is a positive value, then A is better than B. Am I right?
Yes, yes, but you need to check your T. It should satisfy
Yeah,
that
yeah,
your
that's we
T value is
understand.
greater than whatever you look up in that table. Okay.
Yeah, that's we understand.
Yes, yes, yes.
But now the conclusion, our decision making is A is better or B is better.
Yeah, you have to
So
check the
if
mean.
positive things is observed,
Yeah,
then A is better. Negative observed, then
B is.
B is better.
Yeah,
Am I
yeah.
right?
Yes, yes.
Okay.
Okay. Now we have to just do a t-test. The questions 3 to 6 are t-tests.
So please one more explain one more time that the comparison between after watching my T table, how could I will be confirm that A is better than B?
So if the difference of mean between A and B is positive, so mean of A minus mean of B is positive, okay, and your the t value that you get after doing all those calculations is more extreme than the t value you look up in the table. For example, at 0.05 significance, one tailed, I look up for 6 degrees of freedom. My value is 1.95. If I get a t value greater than that, okay, and if my mean of A is greater than mean of B, then I say A is better than B. Okay.
Okay, okay, okay. Thank you so
Okay.
much, sir.
Yeah. Great. Thanks. Archana is raising their hand. Could you please speak up? Okay. Okay, great. Okay.
So no, sir, nothing. It was last previous one I had not raised
Okay.
it on.
Okay. Okay. No problem. So the next thing is again some drug. I don't know. It's a little boring just having drugs, but uh, FDA I think is from America, Food and Drug Administration, I guess. So they are testing two drugs, and yeah, you have just some two data sets.
No, sir, it's about polymer. Don't be something else, sir. It's a polymer.
Yeah, it's a polymer. So they have tested it for certain properties, okay, of the polymer. And
Encapsulation property, I guess.
yes. And you need to just tell whether they are different or not, okay, and something like that. And while doing that, you'll have to do. They've asked us to calculate certain things, which in ANOVA you do, okay. So one is total sum of squares. So this is just math, okay? There's nothing much to talk there conceptually about this. I'll just show you what the formula is, and then you can just calculate. It's there in the lectures also. So one thing that you need to realize what these sums of square are is, suppose I have these data points, okay? These are all blue are my actual data points that I record, okay? Now I try and fit a line through this, okay. What is fitting a line? For example, in Excel you can say fit a trend line, linear trend line. So the computer will optimize and try and draw a trend line that is as close to all the points as possible using some objective. We won't get it in the math. Once the line is drawn, you'll have, if there's another dark blue line that you see horizontal, that is the mean of all these points, okay. So you have all these, so at y, so this has a value of 2, this is a value of 3. How do I know this? This is y axis. This has a value of 4, this is 5, whatever. The mean of all that is given by this horizontal dark blue line. Now sums of squared error is the distance of, say, for this point, okay. This, the error is the distance from the line at that same x value, that is this vertical distance from the line to the point, that is SSE. And you'll have to calculate this distance squared for all the points, okay. So you have to calculate this distance and take the square of it, okay. That is SSE. Uh, and sum it for all the points. So for each point you'll have a value and you'll have to sum, you'll get SSE. SSR is basically the distance of the mean that you get, that you have calculated from the line. That is SSR. This is conceptually what SSE and SSR mean. For each point you'll have this SSR and SSE. You'll have to sum it over. Okay. And then if you sum everything, you get SST. This is your total sum of squared. Okay. Now given that data set, so what I've done is I've already done the calculations. I thought it was a little boring to do it for you. So these were my data points. So for drug A was this, these values, and drug B had these encapsulation values. The mean of The first column is 19.6 and the mean of drug B is 18.4. Their variance was zero point 0.8 and zero point 0.3 respectively. Okay. Now the formula for calculating the overall mean, that is mean of all the samples, like all these 5 samples and all these 5, mean of all these values was 19. Okay. So, yeah, so and the number of samples of each kind were 5 and 5. Now to calculate sum of squared, this is the formula. N1, that is number of samples of type 1 drug A, into mu1, that is mean of the first drug minus the overall mean squared plus whatever. Okay, for the second thing as well. And SSR is nothing but xi, that is for each point. Uh, we have 5 points in group A, right? So for each of that, you have to take each point, subtract it from the overall mean and square it and keep adding. Okay, for all the 5 points, and similarly for all the 5 points for the second thing. And you have to just subtract it from their own mean. So when you do that, you get, maybe I'll make this a little smaller so that you can see. Yeah, so SSE we got as 3.6 and this was actually 4.4. Okay, so yeah, and total sum of square is you need to add both of these SSE plus SSR and you get 8 as a value. This is just math. Okay, the most important thing is to understand what it actually means, what SSE and what SSR is. These are distances in Euclidean space. What Euclidean space is any graphical space. Okay, it's just space between the mean and the line and the actual data point. This helps you to quantify how well the line fits your what you call, not helps us to identify how well, but helps us to tell us whether there are differences with respect to whatever x is varying with y is varying with x and things like that. So this line is basically a model. Okay, but when you do ANOVA, you'll understand what I mean, what fitting models to data is and things like that. Okay. Did everyone get this? This is just math. Not even math, you just have to substitute values.
Is there any other techniques to directly calculate the TSS?
In Excel, yes, but the last time I heard you didn't, you were not allowed to use this thing, no? What you call
Because this is a total sum of square, then if I can utilize all the data systems and do the statistically different
So what you
calculation,
can
then
do, I
possible.
think the equivalent of this is you can just calculate for each data point the value of that data. What is that is? So I'll just write this down. PSS could also be, but I have to check this. I think it's correct. It's the summation of. Oh, but it's for two things. No, I don't think this is correct. Minus the overall mean, but I don't think that's correct. No, I have to check that. But this is the standard way of doing this.
Okay, this formula is from the NOI actually, but
Yeah.
what you are trying to convey right now.
Yes, yes.
But because there the terminology says itself that the total sum of square,
Yeah,
so
yeah.
I think direct calculation might be possible.
Yes, yes. I think what you can do is you can just substitute instead of this mu1, the overall
Okay.
mu, okay, square it for each of the terms. You might get that. So, but I have to check this. I have to actually derive this. It could be this, what the formula, but don't take this as Bible because I'm not very sure. But it's
Okay,
something
we
like
will myself
capital.
I'll do that and verify. Okay.
Yeah, and you can do this for all the so all the 10 data points that you have, and that could give you the TSS, but I'm not very sure. You have to basically show this is equal to this entire thing. Okay, if you can show that, then, but yeah, I don't know whether this is correct.
Yeah, why I am asking because only state calculator is allowed. Scientific calculator will
Yeah,
be
yeah, yeah.
provided during the
Yeah,
examination,
yeah. Yeah,
and no
yeah. Maybe I'll
Excel
just
sheet.
look it up next time. If there's an easier way of doing this, I'll just look it up.
Pardon me.
I'll just look it up next time if there's something easier way of doing this.
Okay, yeah.
Sir,
Yeah.
the terminology you have written on the figure, it is SST, and in the questions it is written as TSS. So,
Ex-
what is the exact terminology we can use for
I think
actually?
this is more correct. So people say sum of squares, total or total sum of squares means the same thing.
Okay, sir. Okay, sir.
Okay. Yeah, yeah.
Okay.
It's not like very recently during the budget there was this minimum alternate tax and alternate minimum tax, which are completely different things.
Yeah, that's why I asked
Yeah,
you
but
this.
this is the same. Don't worry.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Then question four was what is the T calculated? We have done this, okay, but I'll just show you. So yeah, how is the T calculated? T value, this is the formula mu1 minus mu2 divided by square root of this entire thing, that is variance of the first sample divided by number of sample in the first sample, that is squared, plus variance of 2 by n2 squared. Okay, variance is nothing but sigma squared. Okay, if you square a standard deviation, you get the variance. Your null hypothesis is mu1 equals mu2. And for that, and now what is, if you substitute all the values that you have here, so you can get all these values. Okay. If you substitute that into this formula, you get t equals 2.55. Now, the for a two-tailed t-test at 0.05 significance, how many degrees of freedom do we have here? Tell me. So we had, I'll show you the question again. We have 5 data points in each. Okay. So what is the degrees of freedom here? Can
4.
someone?
8 degrees of freedom.
Why 8 now and not 9?
It's n1 plus n2 minus 2.
No, don't tell me the formula. Fine.
For A and for B, the
But
summation is 8.
yes, that's the exact way, correct approach. So if I specify 4 values of A, I know what the fifth value will be. Same thing for B. So 4 plus 4 gives me 8. The formula is n minus 2 actually. It's not the average of both, it's n minus 2, where n is the total number of data points in your entire data set. Okay, but yeah, so yeah, so for 8 degrees of freedom, let's look at the t table once again for a two-tailed t-test. It is for 8 degrees of freedom and for a two-tail of 0.05, it is 2.306. Okay, and the t value that we obtained using all the calculations is 2.55. It's greater than what it is here. So we know that they are unequal. Mu1 and mu2 are unequal. Okay? But you don't know which one is better, greater or lesser than the other. Now you know that mean of 1 is greater than mean of 2. Mean of 1 is 19.6, mean of 2 is 18.4. You do a one-tailed t-test. And what is for t 0.05 at 8 degrees of freedom? If you look up one tail to 0.05 at 8 degrees of freedom, it's 1.860. Okay, and R value is greater than that. So you know it satisfies the one tail t-test criteria also, and you know mu1 is greater than mu2, which using this entire line and the t value that you obtain, you can tell that A is better than B. Okay, did everyone get that step by step? Don't worry about the formula. Okay, the formula I'll send you. It's there in your slides also.
Sir, in the formula we had divided all the nominator with the 5 as a denominator. Why we had put it that 5 in the
Because
denominator?
both have 5, it's common here. Sometimes you can have unequal samples. This is the most basic formula. N1 and N2. Oh, sorry, this is not here. This is not here.
But
Sorry. Yeah, yeah.
oh,
Sorry. That was a typo. So sorry.
That's why I got confused, sir.
Yeah,
Sorry, sir.
yeah. My mistake. My mistake.
Okay, sir.
Okay.
Okay, sir.
This is just formula substitution. Don't worry about that. What's the last question? Degrees of freedom. So degrees of freedom is the number of values in the final. And yeah, just remember the definition I told you. That's like the logic behind calculating degrees of freedom. Yeah. Okay. I think that sort of covers the assign. Your assignment is also very similar to the. You just have different values. Okay. Anything to do with the course content itself? Anyone?
Amir, can you please repeat your question?
So I was trying to ask if there's any more doubts regarding the content or this whatever we have covered so far.
No, I think you explained well.
I have a doubt. In question number 4,
Yes.
the question is what is the mean total sum of square? So whether we should consider degree of freedom as 8 or 9 because it is total.
Yeah. 8 or 9 now. Where it's 8.
The mean total sum of square.
Mean total sum of square you need to divide by the degrees of freedom.
Yes.
Yes.
So since we have two different sample set, whether we should use the formula n1 plus n2 minus 2 or whether we should consider whole set as a single sample.
No, please look up your formula in the I think it's in one of the videos. But I won't tell you this. Please listen to they tell it very
Yes.
explicitly. Okay?
Okay. Yeah.
Yeah.
Thank you.
If I tell you everything, you won't look at the videos. But yeah, it's very simple. If you think over it logically, you'll know. Yeah. Mean sum of squares error is important when you calculate F value. I think next week you'll have this. F value, it's very similar to T value. Like again, you'll have to look up a table for the different degrees of freedom. But yeah. So anything with the course which you haven't understood. Okay, if that's the case, then maybe we can end now. It's a short session, but yeah, I think it was I mean, there was not much to discuss. We just one
Okay, thank you,
assignment.
Amir.
Okay, yeah. Thank you so much, and see you all next week. Okay, and I'll be sharing the video hopefully this time, yeah. Full video and the slides. Okay, thank you.
Thank you so much, sir. यार होस्ट कैसे पता लगेगा प्रज्वल इसमें